In this video, we're going to see what u-substitution does in spirit, but more importantly, we're actually going to see how it relates to chain rule differentiation, like we learned in Calculus A. So to start this, we're going to apply the chain rule to a function that's composed of another function. As in, we have this function h, whose argument is this other function g of x. And remember, when we apply the chain rule, what we actually do in principle is we start differentiating from the outside, moving in. So first we differentiate this function h. Its argument is still that function g of x, again, differentiating from the outside, and then we keep multiplying by derivatives of the stuff inside. So inside of that h function was g of x, so we're going to multiply by the derivative of g of x. So this was chain rule sort of in a most generalized spirit from Calculus A, differentiate from the outside and progressively multiply by derivatives of the inner stuff. Now, how does this actually relate back to u-substitution, or the substitution method for integrals? Well, the next thing we're going to do is we're going to integrate what we just did with the chain rule. So I'm going to take the previous line, and we're just going to integrate both sides now with respect to x. And the first thing we're going to do when looking at this line is start to focus more on the right-hand side, because this right-hand side is sort of where we're going to see a u-substitution actually pop out for us. And let's try to identify that now. So looking at these functions, we notice we have this h prime, who's a function of g of x, but then we have the derivative of g of x sitting there on the end. So for u-substitution problems, what we'd like to see is identify a function whose derivative is sitting there inside of that integral as well, because we hope to cancel out, in this case, that g prime of x, or that derivative, through the substitution. So let's make u g of x in this problem. Again, g of x is the function inside of the bigger h prime function here. So anywhere there's a g of x in that integral, we can replace that now with a u. And now we haven't changed that g prime of x that's in the integrand, so that thing still stays. But the last thing we get to do is we get to change that dx into the new integration variable, a du, for us. And the way we do that is through differentiating our substitution. So again, we're going to look at our u, and we want to differentiate that with respect to x. So let's go ahead and do that now. So we take du dx, and when we differentiate that right-hand side, we will get a g prime of x, the derivative of our substitution. And what we really care about from this part is, well, can we find a dx in terms of the new du that we're looking for? So you can multiply both sides by a dx, so we get du is g prime times dx, and then divide both sides by g prime of x to solve for dx by itself. And that'll be what we plug into our integral in this substitution. So again, we're plugging in for that dx from the original integral and writing it in terms of du, which we now have is du all over g prime of x. And again, the reason we're doing this u-substitution is to try to cancel some stuff out from that original integral through this derivative. And we see from this problem that the g primes, they cancel each other out. And what we're left with in this integral is now the integral of h prime of u du. So we've gotten rid of all the x terms. Our new integral is fully in terms of u. It looks like the u-substitution was successful. And now can we integrate this? And well, if you look at this very closely, what we have is an integral of a derivative, which by the fundamental theorem of calculus, that'll just pass us back the original function. In this case, that'll pass us back, well, an h of u plus an integration constant we'll call c. So what we have left to do now is go back and resubstitute in for the original variable. Again, rewriting u as g of x everywhere in our solution. So we have h of g of x plus c. So you can kind of see how u-substitution and chain rule are related, because this problem basically started out by us differentiating this capital H function that's a function of g of x. However, we didn't look at the right or the left-hand side of this integral that we had, and actually this left-hand side also pops out of fundamental theorem of calculus for us, because this looks like we have the integral of a derivative. So this left-hand side for us as well, this actually just gives us back h of g of x, since the integration you can think of as undoes that differentiation in the integrand. And of course, we get an integration constant. So you can basically see how both sides of these are all related, how a chain rule can be undone using a u-substitution type method, and that's how we can identify this relationship between chain rules differentiation and u-substitution.